So for what we're working on for today, today is going to be applications. So we're doing the same approach with the solving. That's not going to change. It's just that these are story problems. Okay? So I looked up and did some research, looked up some different techniques of how to do these, and then I kind of found one that I thought was probably going to be best, so like a best fit. So anyways, so what you kind of have things, it's like things that are making like one kind of unit. So here we're looking at, Mike washing a car compared to Ray washing a car, but they're still washing a car, same car, okay? So a lot of times when you're going to set these up, there's a certain kind of approach that works really, really well with that. So right now we're going to have X represent the time it takes together to wax and wash the car. So Mike's time plus the other person's time, Ray's time, together will work together on one car. Yes. Okay. So it's always going to equal 1 because you've got, Mike's time and then Ray's doing it, and they're still going to be doing the same car. So what we're going to be first looking at is the time together I don't know. And there's a couple of ways to do that. I like putting my time it takes together on top. Okay? So I don't know how long it takes for Mike to do it together with Ray. But I do know underneath how long it takes just Mike to do it. So that's 4.5. So I'm going to just change this to 4.5. So again, time it takes together, don't know, over Mike's individual time. Plus, because remember they're working together, so I don't know the time together that they have, but I know that Ray's individual time is 3 hours.
Don't you know the time together? Just add them.
No, not yet. And they're still equaling 1 car. You could also, by the way, make a table of values and kind of like go by like hours, like how much of the car is complete and things like that. That takes a lot more work. And so, again, I looked at all the different strategies, tried to find the one that would be the best fit, that would be easiest. So, just like what we were doing before, what do we need to do with this? No. Common denominator. So we need a common denominator. So not really, because 9. 4.5 and 3 have 9 in common. So therefore, I have to think 4.5 times what makes 9? 2. So we're going to multiply this top by 2, so it's going to become 2x. And then we have the 3 on the bottom. We now need to create it to be 9. So I need to multiply the bottom by 3, so I got to multiply the top by 3. Okay? Now, since my two fractions match, I can put them together. So we're going to have 5x over 9 equals 1. Now, I'm just going to get rid of the divide by 9. How do you get rid of a divide by 9? Multiply. So we're going to multiply by 9 both sides, and we'll get 5x equals 9, and then divide by 5 to finish the problem. And so we're going to have, well, yeah, we could probably change it to a fixed number because it's a story problem, So it's going to be 1 4/5, and then we need hours because that's my label. Or if I wanted to convert it in exactly how many hours and how many minutes it would be, I could take the 4/5 and multiply that by 60. And so if I wanted to be more technical, it would take 1 hour and 48 minutes because I'm going to do 4/5 times 60 because, again, there's 60 minutes in an hour. That would be the best answer. But, again, if you left it as 1 4/5 hours, I'm going to be okay with that. Okay. Questions on that? Okay, Louise.
Why is that equal?
Because they're still working together on one vehicle. So it's always going to equal 1. So we're always going to be talking about how long does it take to work together on this one vehicle, or how long does it take to fill this tank, one tank. It's always just talking about one thing that's getting completed. So that's kind of why it's doing that particular one. Now this next one's kind of different than the first one. It's kind of got the same mapping to it, but the only thing that's a little bit different is this time we know how long it takes for them to work together. So first is we know that Mary takes twice as long as Carol does to make a display case at school. Then together it's going to take 4 hours for them to do the display case. So we need to figure out how long does it take Mary to do it herself.
8.
Okay, so first thing we're going to do with this one, this time we know the time it takes together, so I can't call that X. We eventually want to find Mary's, but I found that it's actually easier if we call X. That is going to be Carol's time. So that's going to be Carol's individual time it takes to do the display case. So really, Carol's time plus Mary's time equals 1 display case. So only 1 display case is getting done. Okay, so for this particular problem, this time X's will not be in the numerator because I know what time they have together. So that is going to turn out to be 4. So in this particular problem, 4 is going to be in the numerator because that's the time, again, together. So the together time always goes up on the top. Okay, under the first one, let's focus on Carol first. So we don't know how long it takes Carol to do the display case. So we're going to call that X because that's what I defined her time as. So it's X. I don't know how long it takes for her to individually do it. Okay, then now we got to go to Mary, but Mary takes twice as long as Carol.
X squared.
So it's 2X.
2x.
Twice, remember twice means times 2. And so this is my initial equation. No, because we're adding. So we're going to have to get a common denominator again. So we're going to need a 2x. So we're going to need to multiply the bottom by 2. So we're going to multiply the top by 2. So we're going to get 8 over 2x. And then this one's fine the way it is. So it's just going to be 4 over 2x. Okay, and then we can add. So what would we get if we add our numerators? So 12 over 2x. And then do what we did before. I don't want to divide by 2x, so the opposite of dividing
6.
is to multiply. 6 is not our final answer, but that's getting us there, yes. So we will end up getting 12 equals 2x, and then divide by 2. Now, x is 6, that's true, that's Carol's time. But the question is, it didn't ask for Carol's time, it asked for Mary's time. 12. 12. Because Mary takes twice as long.
Okay, well, I have a question.
Yes, it did. So 12 hours. Yes, question?
Can you multiply 12 each side, or does it matter?
No, because the 12's on top. You don't want to multiply it by 12.
I hit it.
Well, then you got lucky. So my answer to that problem is going to be 12 hours. Okay, last example.
Times 2.
This one, are we always adding like fractions together? Well, not necessarily in this case. This one's kind of dealing with piping, and so this one is going to be involving filling the tank, but also draining the tank. So we have 3 pipes. We're just assuming if all 3 pipes were open, again, it doesn't necessarily, it's just kind of a scenario. So if we have 2 pipes are used to fill in a water tank, the one can fill it in 27 minutes. The second one can fill it in 54 minutes. But the third pipe is going to be the drain, and that can empty the whole tank in 36 minutes. So let's just say, not that we would, but if we had all 3 of those tanks, like particular pipes open, then how long would it take for just the tank to be filled? Okay, so anyway, so we're going to have pipe 1 plus pipe 2, because they're both filling it. But pipe 3, am I really going to be adding?
Minus.
We're going to minus. And that's still going to make 1 tank. That's not going to change. All right? So therefore, again, we can talk about we don't know the time that they are together. It's a lot like our first example that we had. So I'm going to have X represent the time they had together. So the time together to fill the tank. All right. So this time, unlike the last example where the numbers were in the numerator, that's not going to happen. It's going to be more like our first problem. So the first pipe, I don't know the time together, but I do know the time alone. So that's 27. Then we're going to have X again, don't know time together, individual time 54. Next, subtract, don't know time together, and then we need that time for the drainage pipe. So that's 36. And again, it's going to equal 1 because we're wanting one full tank. Okay. This one's a little bit harder because we have to kind of come up with a common denominator.
9.
Try 108 people.
9.
36 does not go into 54.
Oh, yeah. Okay, that's my...
So we need 108 as a common denominator. You know, because first when you look at it, it's, you know 27 goes into 54, but then you have to kind of think about the 54 and the 36, and 108's the best because 54 times 2 is 108, and 36 times 3 is 108.
So it's 4x.
So, yes, so this needed to be multiplied by 4. So this is going to be multiplied by 4. This one is going to be multiplied by 2. So I'm going to get 2x. And this one's being multiplied by 3, so I need to multiply the numerator by 3. But be careful. Now I can put together my things. I can put together my numerators. So 4x plus 2x minus 3x is going to be 3x over 108 equals 1 times both sides by 108. And we'll have 3x equals 108 and then divide by 3. And then we'll get our final answer, which is going to be 36 minutes.
Half an hour and 6 minutes.
And that's it for the examples for that.